Today we're working on lesson 6.7, subtraction and renaming fractions, and how can you use renaming to find the difference of two mixed numbers. What are mixed numbers? They have a whole number,
and a fraction.
And a fraction. Okay. Let's read our problem first. To practice for a race, Kara is running 2.5 miles. When she reaches the end of her street, she knows that she has already ran 1 5/6 miles. How many miles does Kara have left? Okay, one way to accomplish finding that answer is to rename the first mixed number. Subtraction. 2.5 minus 1 5/6. So let's estimate. What are our benchmarks for fractions? 0,
1,
half, and
1.
Very good. So we have the whole number 2, and then we have 1/2. So are we going to change that one? No. And now we're going to take away 1 5/6. What are we going to do with 5/6?
2.
Round that up to 1. So 1 plus 1 would be 2. So we should have an answer that is around 1/2. Find a common denominator. Use the common denominator to write equivalent fractions with like denominators. Now they chose to use 12s. What other denominator could we have used?
6.
6. Okay. Whoops. Rename 2 6/12 as a mixed number with a fraction greater than 1. Because you'll see here we have 6/12 and 10/12. Can I take 6, have 6 and take 10 away from that? No. So we're going to have to regroup just like we do when we are doing subtraction without fractions. First of all, what is a whole number that 12/12 is equal to? 1. If I cut a pie into 12 pieces and nobody eats any of that pie, there are still 12 pieces left. So 12/12 of the pie, or one whole pie, is still there. Okay, so we want a fraction greater than 1. What are we going to do to get some more 12s here? Okay, we're going to make the 2 into a 1. Okay, so now we have this 1 hanging out here that we're going to do what, Tegan?
Take it and make it into 12 and add it to the 6.
Okay, so then how many 12s are we going to end up with? 18. 1 and 18 12. So we took 1 away from our whole number. We made that into the fraction 12/12, and we added 12 12/12 to the 6/12 we already had to give us 18/12. Now we can subtract. What are 18/12 minus 10/12?
8/12.
8/12. And 1 whole minus 1 whole? 0. Then what are we going to do? Simplify. What number can we divide evenly into both of those? 4. So 2/3. Here's how they broke it down to show you making that 1. So they split their 2 into 1 plus 1. And then they have the 6/12. Then in the next step, they take this second 1 and they make it into 12/12 so that you get 1 and 18/12. Anybody have any questions on that? Find the difference of the fractions. Then find the difference of the whole numbers. Write the answer in simplest form. Check to make sure that your answer is reasonable. So our answer then is 2 thirds, is 2/3 close to 1/2?
Yes.
Yes. It's a little bit over because 1/2 of a third would be 2 1/2. I mean 1 1/2. So, or 2/3 is, okay, so let's move on. Now we are on page 270. Let's look at the explain on the bottom of 269. What would it be there? It says, why is it important to write equivalent fractions before renaming?
So you know if your answer is close to your...
Well, why is it important? Okay, if you're listening to this recording, we're going back to page 269 at the bottom where it says explain. And the question there is, explain, or what they want you to do is explain why it is important to write equivalent fractions before renaming. We wouldn't want to rename first because we might not need to by the time we make our fraction equivalent. Okay? Okay, so before you go to all that work of renaming the fraction, you need to get them equivalent to make sure that that renaming is necessary. Okay, here's another way. Okay, so we're going to rename both mixed numbers as fractions greater than 1. Now, if I take 2 3/6, and I want it to be a fraction, it doesn't say anything about a whole number, I need to take this 2, and that would be 1 plus 1 plus 3/6, right? But since I want everything to be a fraction, I have to have 6/6 plus 6/6 plus 3/6. And that gets me 15/6 when I add this. If I take my 1 5/6, I change my 1 into 6/6 plus 5/6, I get 11/6. And when I subtract those, I get 4/6, which can be simplified to 2/3. So again, we got the answer of 2/3. Okay, this is number 1 on page 270 on the bottom of the Sharon Show. We're going to estimate 1 3/4. What are we going to estimate that to? 3/4 is almost 1.
Oh.
So 1 plus 1 is
2.
2. Minus 7/8 is almost 1. So 2 minus 1 is 1. So our answer should come out somewhere near 1. Now we're going to take 1 3/4. I like to write them under each other. Okay? What common denominator can I use for 4 and 8? 8. Okay? So am I going to have to change 7/8? No. So I can subtract 7/8. So minus 7/8 to equal here. Now we've got to do something with 3/4. So what am I going to multiply 3/4 by?
2.
We're going to keep our whole number at this point, and we're going to multiply this times 2. So 6/8. Now, if I have 6/8, can I take away 7/8?
No.
No. So now we're going to have to rename this 6/8, or 1 6/8. So 1 could be renamed to 8/8, right? Plus our 6/8 to equal 8 plus 6 is 14/8. Take your 7/8 and put it over here. We're minusing 7/8 to get an answer of 7/8. Is 7/8 close to our estimate of 1?
Yes.
Yes, it certainly is. Okay, this is number 2 at the bottom of page 270. Then we're going to estimate 12 1/9. What is 1/9 closest to?
0.
0. So we have 12 minus 7 and 1/3, what is 1/3 closest to?
0.
0. Or it could be
1/2.
1/2. They use 1/2, so we'll try 7 and 1/2. What is 12 minus 7?
5.
5. Then we have to take another half away, so we're going to be at 4 and 1/2 for our estimate. Okay, so let's look at this. 12 and 1, we have ninths and thirds. What is going to be our common denominator?
9.
9. So I have 12 and 1/9 minus 7 and 1/3. I've got to make those thirds into ninths, so I'm going to have 7 and 3/9. Sorry. 7 and 3/9. And this is going to be equal to 12 and 1/9. Now, if I have 1/9, can I take 3/9 away?
No.
No. So now we've got to name this. Take one whole away, so that would give us 11. That would give us 9/9 to add to our 1/9, which would be 10/9. And now we can subtract 7 and 3/9. And 10 minus 3 is
7.
7/9, and 11 minus 7 is 4. So we have 4 and 7/9. Can we simplify 7/9?
No.
No, 7 is a prime number.